Hi class, I'm Desmond Edagese. Welcome to Maths class. Today, we'll be looking at the theme number and numeration, and our topic is number-based systems part 2. I hope you took a look at the first part. With that, you'll be able to understand better what we'll be doing in our part 2. Let's take a look at what we'll be looking at in the part 2. Okay, in our part 1, we learned about the number-based system and the different types of number-based systems that we have. We took particular notes about number-based systems such as base 10, base 2, base 8, and base 16. Well, in this part, we'll be looking at how we can convert, okay, from one base to another base. So we can move or change a number from base 2 to base 10, or even from base 2 to base 5, or from base 5 to base 8, and different kinds of conversion of bases. So we'll look at conversion from base 10 into other bases, conversion from other bases into base 10, conversion from one base into another base, conversion from binary, that is base 2, to octal, that's base 8, conversion from octal back to binary, conversion from binary into hexadecimal, that is from base 2 to base 16, and also how to convert from base 16 back to base 2. It promises to be a loaded class that will be exciting. Let's go on. Now, we'll be looking, first of all, at how to convert numbers from base 10 into other bases. Now, there are 3 simple steps to convert a number from base 10 into another base. First step, divide the base 10 number by the new base that you want to convert it to. Next, continue dividing, okay, until 0 is reached. And finally, write down all the remainders, okay? So we are concerned mostly about our remainders in this case, but read them upwards, that is from down upwards. Let's take a look at a typical example, and then we'll follow our steps. Convert 5 base 10 into base 2. How do we do this? First, divide our base 10. Our base 10 is 5. So divide it by the base in which you want to convert to, which is base 2. So we say 5 divided by 2. That gives us 2. Okay? That's our quotient. And then we have a remainder 1. So 5 divided by 2 is 2, remainder 1. Now, this 2 that we have as a quotient is again further divided by the same base, 2. So we have 2 divided by 2. It gives us 1, okay, as our quotient. And then we have a remainder 0. Finally, remember we are to divide until 0 is reached, okay, until 0 is reached. So again, our quotient here, 1, is further again divided by 2. Of course, it is smaller than 2. 2 in 1 is 0. It's impossible. No, well, let me not use the word impossible. 2 in 1 cannot go, so we simply say 0. Okay, and then we have a remainder 1. The same 1, of course, is returned back. So we have a remainder 1. Now, the last step says write down all the remainders and read upwards. Write them from down up. Okay, so we have 1, which is our last remainder. We have 0, then we have 1. So we say 5 base 10 is 1, 0, 1 in base 2. So that is how to convert numbers from base 10 into other bases. Let's take a look at another example. Convert 140 base 10 into base 8. So again, we simply divide 140 by our base 8, and we keep dividing until 0 is reached. When we get to the last 0, again, we read the numbers up, and that will be the number of our base 8. So let's start. 140 divided by 8 gives us 17, and we have a remainder of 4. That 17 again is further divided by 8. It gives us 2. That's 16, remainder 1. Okay? So we have 2, again further divided. Of course, 8 cannot go in 2. We have a 0 there. Remember, we are dividing until 0 is reached. So we have reached 0, but we have a remainder of 2 because 2 is returned. We count our numbers from down up. Our remainders from down up. So we have 2 as a remainder, 1 as a remainder, 4. 214 is the base 8 number of 140 base 10. So 214 base 8 is the correct answer. Again, let's convert 75 base 10 into base 4. So we divide 75 by 4 and keep dividing until 0 is reached. 75 divided by 4 gives us 18, remainder 3. 18 divided by 4 gives us 4, which is 16, remainder 2. 4 in 4 gives us 1, remainder 0. 4 divided by 1 gives us 0, remainder 1. So we have reached our 0 point here. Now we write down our numbers from the last remainder to the first remainder. We have 1, 0, 2, 3. 1, 0, 2, 3 base 4 is our answer. Lastly, for converting from base 10 to other bases, let's take a look at this example. Convert 75 base 10 into base 2. So 75 divided by 2 gives you 37, remainder 1. 2 in 37 gives us 18, remainder 1. 2 in 18 gives us 9, remainder 0. 2 in 9 gives us 4, remainder 1. 2 in 4 gives us 2, remainder 0. 2 in 2 gives us 1, remainder 0. 2 in 1, of course, gives us 0. So we've reached our 0 points, remainder 1. We simply write down our remainders from down up. We have 1, 0, 0, 1, 0, 1, 1. So 1, 0, 0, 1, 0, 1, 1 is our base 2 number as 75 base 10, or in other form, 75 base 10. So remember, in the first video, we learned that binary numbers are made up of zeros and ones. So you have a binary number there, 1, 0, 0, 1, 0, 1, 1, base 2. Next, we'll look at how to convert from other bases into base 10. Okay? To do that, we follow 3 simple steps. We write down the number in its expanded positional form. Next, we list the power of the base represented above each digit in the number. And then we add, finally, we add and multiply through to get our base 10. We'll apply these steps into some examples for better understanding. If you were asked to convert 235 base 8 into base 10, following our steps, we'll write this same number, 235 base 8, in its expanded positional form. Okay? So we write down every digit 2 first, times the base 8, raised to a power 2. Okay, 235, okay, made up of 3 unique digits. All right? In positional form, this 5, okay, occupies the 0 position. 3 occupies the 1 position, and our 2 here represents the 2 position. Okay, it follows as the number of digits within our number increases. So if we have another number here, that number occupies the 3rd position. All right, so 235 here we'll rewrite as 2 times 8, which is our base, raised to the power 2. So first, maybe somewhere on your piece of paper, quickly indicate the positional exponents on the numbers so that we can quickly write them down when we are expanding it. We have 2 times 8 raised to power 2, 3, which is our next number, times 8 raised to power 1, 5 times 8, which is the base, raised to power 0. Okay? Next, we simplify them by writing down all our numbers. For instance, 8 raised to power 2 is 64, of course. So we have 2 times 64 plus 3 times 8 raised to power 1 is 1. 5 times 8 raised to power 0. Anything raised to power 0 by the laws of indices is 1. So we have 5 times 1. All of that gives us 128 plus 24 plus 5. And all together gives us 157. So we have 235 base 8 has given us 157 in base 10. All right, so we've applied all our steps. Let's take another example. 1011 base 2. We've been asked to convert it to base 10. Again, we list the powers of our base. The powers of our base, okay? That is the exponents. Let's quickly do that here. So we'll always remember 0, 1, 2, 3. Okay? So we expand 1011 as 1 times 2 being the base raised to power 3 plus the next number is 0 times 2 raised to the power 2, okay, plus 1, which is the next number, times 2, our base, raised to the power 1, plus 1, the last number, times 2 raised to power 0, okay? So we expand that to be 1 times 8, plus 0 times 4, plus 1 times 2, plus 1 times 1. That gives us 11 in base 10. So 1011 base 2 is 11 base 10. Let's take a look at another example. Convert 1C4 base 16 to base 10. I guess we already remember what C stands for. Okay? C stands for 12. Remember we learned in the first video in the hexadecimal naming, okay, of the peculiar digits in the system. C stands for 12. So this is same as saying 1, 1, 2, 4, base 16. Okay, but it's written in this form, 1C4 base 16 to base 10. All right, so we quickly expand this 1 times 16 raised to power 2 plus 12, C is 12, 12 times 16 raised to power 1 plus 4 times 16 raised to power 0. It gives us 1 times 256 plus 12 times 16 plus 4 times 1, which gives us 256 plus 192 plus 4. Total giving us 452. So we have 1C4 base 16 gives us 452 base 10 for an answer. Let's do the last one for the conversion from other bases into base 10. Convert 1264 base 8 into base 10. All right, so we quickly expand that. Let's quickly write down our powers. 0, 1, 2, 3. So you will remember 1 times 8 being the base raised to the power 3. Okay? Plus 2 times 8 being the base raised to the power 2. Okay? 6, our next number, times 8 being the base raised to the power 1. And plus 4 being the last number, times 8 raised to the power 0. All of that simplified gives us 692. Of course, 1264 base 8 ends up being 692 base 10 as our answer. Now, next, we'll be looking at another type of conversion. How to convert from one base into another base. Now, to convert from one base to another base, we follow two simple steps. First, convert the given number to base 10. Okay? Of course, you get a certain value. That value, again, is converted back now to the required base that we required from the very beginning. Example, we've been asked to express 4140 base 5 to octal. That is, convert 4140 base 5 to base 8. Okay, to do that, we'll follow our steps. First, we'll convert 4140 base 5 to base 10. And then we get a value. That value will now convert to base 8. So let's go ahead. To convert 4140 to base 5, of course, we'll write our 4140 base 5 in its expanded positional form. Okay, taking note that our powers would be written down somewhere so that we can remember easily. So we have our powers written above them. Let's go ahead to write down their positional form. We have 4 times 5 being the base, okay, raised to power 3, plus 1, the next number, times 5 raised to power 2, plus 4 times 5 raised to power 1, plus 0 times 5 raised to power 0. All of that numbers are simplified to give us 500 plus 25 plus 20 plus 0, and that gives us 545. So 4140 base 5 is 545 base 10. Now 545 base 10 is further on also converted to base 8. To convert 545 base 10 to base 8, like we learned earlier, okay, we simply divide 545 by 8 continuously until we get to 0. And then we put down the remainders counting from bottom up. Let's go ahead to do that. 545 divided by 8 gives us 68, remainder 1. 68 divided by 8 gives us 2, remainder 4. And of course, 8 cannot go in 2, so we've hit our 0 level. Okay, and the last remainder there is 2. 2 is returned. So we have counting or writing from bottom up, our remainders are 241. So 241 base 8 is, okay, same as 4140 base 5. Let's take a look at another quick example. Express 143 base 6 to base 7. So following our two steps, first, convert 143 base 6 to base 10. To do that, we expand 143 base 6 and we write it in the expanded positional form. Our powers, beginning from the last digit there, is 0, 1, 2. Okay, we just put them down somewhere for reference sake. Now let's go ahead to expand it. We have 1 times 6 is our base here. 1 times 6 raised to power 2 plus 4 times 6 raised to power 1 plus 3 times 6 raised to power 0. All simplified to give us 64 plus 24 plus 3, 91 base 10. Okay, so 143 base 6 is 91 base 10. But remember, we've been asked, okay, to give the answer as a number in base 7. To get 91 base 10 in base 7, we'll divide 91 continuously by 7 until we reach the 0 level, and then we write down our remainders. Okay, let's follow our steps. 91 divided by 7 is 13, remainder 0. 13 divided by 7, it goes 1 time, remainder 6. 7 cannot go in 1, so we've hit our 0 level. So we have 0, remainder 1. 1 is returned here. So we count our remainders, from down up, and we have 160 base 7 as our answer. 143 base 6 is same as 160 base 7. Let's take one last example there. Convert 328 base 7 to base 5. So first, we'll convert 328 base 7 to base 10. Writing it in an expanded positional form, we have 3 times 7 raised to the power 2 plus 2 times 7 raised to the power 1 plus 8 times 7 raised to the power 0. That gives us 147 plus 14 plus 0, which gives us 161 base 10. 161 base 10 is further on converted to give base 5. To have our answer in base 5, we divide 161 by 5 continuously until we get to the 0 level. Okay, so 161 divided by 5 gives us 32, remainder 1. Okay, 35 in 32 is 6, remainder 2. 5 in 6 is 1, remainder 1. 5 in 1 is 0. We've hit our 0 level, remainder 1. So we stop dividing, and then we take the remainders. We have 1121 base 5 as our answer. Next, next we'll be looking at how to convert from binary number system to the octal base. From binary to octal base, that is from base 2 to base 8. Okay, to convert from base 2 to base 8, we follow two simple steps. 1, divide our digits into groups of 3, starting from the right. When you've done that, convert each group to one octal digit using the decimal conversion. Example, convert 11011010 base 2 to base 8. Okay, so we have our binary number here, 11011010. We're now asked to convert it to base 8. First step says, divide the digits into groups of 3, starting from the right. Okay, So let's begin from our right. We have 0, 1, 0. Okay, first group. Next, we have 1, 0, 1. Second group. Okay, we have the last number 1. Okay, our groups must be in 3 digits. So we have 1, and then we impute 2 zeros before our 1 to complete our 3 digits. So 1 and then 0, 0 before that 1 gives us our 3 digits. So we have our 3 digits. Next step says convert each group to 1 octal digit using the decimal conversion. Okay, so convert 001, 101, and 010, okay, to base 10. To do that, of course, remember we'll write it in the expanded positional form. So we have 0 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. Of course, 0 cancels out, 0 cancels out. We have 1 times 1, which is 1. The next one, we have 101 base 2. Okay, in base 10, we'll expand that to be 1 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. Okay, 1 times 2 raised to the power 2 is 1 times 4. 0 cancels out. And then 1 times 2 raised to the power 2 is 1 times 1, which is 1. So we have 4 plus 1, it gives us 5. All right, lastly, we have 010. Convert to base 10. You have 0 times 2 raised to the power 2 plus 1 times 2 raised to the power 1 plus 0 times 2 raised to the power 0. 0 cancels out here. We have 1 times 2 raised to the power 1, which is 1 times 2, gives us 2. 0 cancels out here too, so we have 2. All right? So now we have our numbers. Now our final answer is a combination of the individual decimal converted numbers that we have, 1, 5, and 2. So we write down 152 base 8. That is our answer. Let's take another quick example. Convert 1011012 base 2 to base 8. Now again, we follow our 2 steps. Divide the digits into groups of 3, starting from the right. So let's do that. We have 1, 2, 3, which is our first 3 numbers. Next we have 1, 1, 0. Okay? So we have next as the next 3 digits. And then we have 1 again left. Okay? But we've been asked to divide into groups of 3. To fill the other 2 spaces, we fill that with 0. So we have 0, 0, 1 as the other digits. We have our divisions, okay? We've been asked next in the next step to convert each group to 1 octal digit using the decimal conversion. So we convert this, this, and this and get individual single digits for them. 001 base 2 can be written, okay, as a base 10 in the expanded form, saying 0 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. 0 cancels out, 0 cancels out. We have 1 times 2 raised to the power 0, which is 1. 1 times 1 is 1. Next, we have 011 base 2. We have 0 times 2 raised to the power 2 plus 1 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. 0 cancels out. We have 1 times 2 raised to the power 1 is 2. 1 times 2 is 2. Plus 1 times 2 raised to the power 0, which is 1. 1 times 1 is 1. 2 plus 1 gives us 3. And next we have 011 base 2, which is a repetition, okay, of what we calculated here. So we'll simply have 3. All right, we'll write down our numbers as 133 base 8. So 1011011 base 2 is successfully converted to 133 base 8. Now, another kind of conversion is conversion from the octal back to the binary. That is from base 8 back to base 2. To do that, first, we'll follow 2 simple steps to convert a base 8 to base 2. First, convert each octal digits into 3-digit binary numbers. Remember to treat each of the octal digits as a decimal, that is as a base 10. Finally, we'll combine all the resulting binary groups that we've created into one binary number. Example, convert 562 base 8 to base 2. So we are treating each digit there as 5 base 10, 6 base 10, 2 base 10, okay? We're treating them as individual digits. To convert this to base 2, 5 base 10 to base 2, what do? We divide 5 continuously by 2, which is our required base, until we get to 0 level. Okay, so 5 divided by 2 is 2, remainder 1. 2 in 2 is 1, remainder 0. 2 in 1, of course, we've reached our 0 level. We have 0, remainder 1. So we have our binary digits for 5 base 10. Next, we'll treat 6 base 10. Okay, to convert to base 2, we divide continuously by 2 to get 6. 2 in 6 gives us 3, remainder 0. 2 in 3 gives us 1, remainder 1. 2 in 1, we've reached our 0 level. Okay, gives us 0, remainder 1. So we have our binary digits also, okay, for 6 base 10. The last one, 2 base 10, we divide continuously by 2. We have 2 in 2 is 1, remainder 0. 2 in 1 is 0, remainder 1. So we have 1, 0. We have 3 binary groups. Okay? We have 1 binary group, 2 binary group, 3 binary groups. The last step is combining them into one binary number. So 5 base 8 is 101 base 2. 6 base 8 is 110 base 2. Okay? And 2 base 8 is 010 base 2. All right? So we've been asked to combine them. So we simply say 101 combined to 110 combined to 010 base 2. So 562 base 8 is same as 101110010 base 2. Now let's try another example. Convert 472 base 8 to base 2. Okay? So again, we'll convert each digit. We'll treat it, okay, as a base 10. That is each digit. So we have 7 base 10, we have 2 base 10. And then we'll convert each, okay, to its 3 binary digits. So we have 4 divided by 2. This would give us 2. Okay, 2 remainder 0. 2 in 2, 1 remainder 0. And 2 in 1, 0 remainder 1. Also, 7 divided continuously by 2. It gives us 3 remainder 1. Give us 1 remainder 1. To give us 0 remainder 1. And lastly, 2 and 2 gives us 1 remainder 0. 0 remainder 1. So we have 3 groups of binary numbers. We combine them to have our answer. And that will be 1, 0, 0, 1, 1, 1, and 0, 1, 0, all in base 2. Okay, so we combine this, and this to give us this. So 472 base 8 is same as 100111010 base 2. Next, we'll look at how to convert binary numbers to hexadecimal numbers. That is from base 2 to base 16. To do that, we'll follow 2 simple steps. First, divide the binary number into groups of 4, starting from the right. Okay, next, each of those groups will be converted into one hexadecimal digit using a decimal conversion. All right, let's take an example. Convert 11101 base 2 to base 16. Okay, following our steps, we will separate our binary number into groups of 4. All right, let's take the first group starting from the extreme right. We have, okay, 1101 as the first number in the group. Okay, we are left with two numbers, 1, 1, okay? But we said groups of 4, so we must fill those spaces. We fill them with 2 zeros. Hence, we have 0, 0, 1, 1. Next, we'll convert each of these groups, group 1, group 2, into one hexadecimal digit using decimal conversion. Okay, to convert into a decimal number, okay, we expand it, okay, by saying 0. Of course, 0 will cancel out anyway, so we have 1 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. 1 times 2 raised to the power 1 gives us 2, plus 1 times 3 raised to the power 0 gives us 1. 2 plus 1 gives us 3. Next, we'll handle the second group, okay? 1 times 2 raised to the power 3 plus 1 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. And that gives us 8 plus 4 plus, this is 0 and this is 1. So we have 8, 4, and 1 added to give us 13. All right, in hexadecimal form, remember 13 is represented by a letter. That letter is D. So we combine the two numbers or two digits gotten from our conversion to add to give us the number in base 16. We combine 3 and D to give us 3D base 16 as our answer. Example 2. Convert 11011 base 2 to base 16. Okay, again, following our steps, we separate our binary number into two groups of 4. Taking from the extreme right hand, we have this. So we have 1011 as our first. Okay. Next, we are left with just 1. We need to fill the remaining space to make it a group of 4. With zeros, we have 0001 as the next group. So let's take this as our group 1, this as our group 2. Group 1 is then converted using decimal conversion, okay? So we convert by expanding it, okay, in the positional form. 0, 0, 0, of course, they will all cancel out eventually, so we have them as zeros. We're left with 1. 1 times 2 raised to the power 0. 2 raised to the power 0 is 1, so 1 times 1 is 1. Next group, 1011 base 2. So we expand this positionally to give us 1 times 2 raised to the power 3 plus 0 cancels out, plus 1 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. 1 times 2 raised to the power 3 is 8. 1 times 2 raised to the power 1 is 2, that's 10. 1 times 2 raised to the power 0 is 1, that's 11. So we have 1 and 11. But remember in hexadecimal, okay, numbering, 11 is represented by the letter B. So we have a combination of 1 and B. So we have 1B base 16 as our answer. Next, we'll be looking at how to convert from hexadecimal base into binary base, that is from base 16 to base 2. To do that, there are two simple steps. First, convert each hexadecimal digit into 4-digit binary numbers, okay? While doing that, treat the hexadecimal digits as decimals. Next, combine all the resulting binary groups into one binary number. Let's take a typical example. Convert 2AB base 16 to base 2. Okay, our first step says convert each hexadecimal digit. So we divide it quickly into 2 digits. We have 2A and B base 16. But we are treating it as decimal numbers in order to convert them to base 2. Okay, to convert to base 2, we'll divide each digit repeatedly by 2 until we get 0 results. So 2 in 2 gives us 1 remainder 0. 2 in 1 gives us 0 remainder 1. So we have a 2-digit binary number. But remember, it's meant to be 4. So we make that up by adding 2 extra zeros. All right, so we have 0, 0, and then we have 1, 0. Base 2. We have our first binary number. Next, we treat A. A, of course, in hexadecimal notation is 10. Okay, so we divide 10 repeatedly by our required base, which is base 2. 10 by 2 gives us 5, remainder 0. 2 in 5 gives us 2, remainder 1. 2 in 2 gives us 1, remainder 0. 2 in 1 gives us 0, remainder 1. So we have our 4-digit binary number, which is 1010 base 2. And lastly, we have B. B, of course, is 11. Okay? So we divide 11 repeatedly by 2. That gives us what? 5, remainder 1. 2 in 5 gives us 2, remainder 1. 2 in 2 gives us 1, remainder 0. 2 in 1, okay, gives us 0, remainder 1. So we have 1011 base 2 as the third binary number. So the next step is combine all the binary groups. So we combine 0010 and 1010 and 1011. That will give us a joint binary number there, 001010101011 base 2, and that's our answer. Next, let's try this example. Convert 2e6 base 16 to base 2. Following the same steps, okay, we'll separate them into their digits. So we have 2, we have e, and we have 6. Okay, we treat them as decimal numbers in order to convert them to binary numbers. So we say 2 divided repeatedly. We already know that to give us 0010. Okay, E is what? 14. Good. So we divide 14 repeatedly. We have 7, remainder 0, 2, 3, remainder 1. 2 in 3 gives us 1, remainder 1. 2 in 1, of course, gives us 0, remainder 1. So we have 1, 1, 0 as our binary number. Okay, lastly, we have 6. Divided repeatedly by 2, we have 3, remainder 0, 1, remainder 1, and 0, remainder 1. So we have 110. But remember, we need 4-digit binary numbers. So we add an extra 0 to give us 0110. The next step is to add up all our binary groups into one general binary group. So we add this binary group to this binary group and this binary group. So we have 0010, 1110, and 0110 base 2 as our answer. And so we've come to the end of our class for today. But let's take a quick look at some of the things that we learned, okay? In the course of our class today, we learned basically on how to convert bases from one base to the other. We learned how to convert from decimal base to other bases. We learned how to convert from other bases to decimal bases. We learned how to convert from one base to another. We learned how to convert from binary, that is base 2, to octal, base 8. We learned how to convert from octal to binary, that is from base 8 to base 2. We learned how to convert from binary to hexadecimal bases, that is from base 2 to base 16. And lastly, we learned how to convert from base 16 to base 2. All right, now to confirm if we remember how to do all the calculations that we learned, we'll take 2 quick questions before we end our class. First question, convert 53624 base 7 to the corresponding decimal number, okay? To do that, remember we said to convert from any other base to base 10, we'll simply write out our given number in its positional form, okay? Then we'll have our required number. So we write 53624 base 7 expanded in its positional form to be what? 5 times 7 raised to power 4 plus 3 times 7 raised to power 3 plus 6 times 7 raised to power 2 plus 2 times 7 raised to power 1 plus 4 times 7 raised to power 0. Okay, we said that gives us 5 times 2401 plus 3 times 343 plus 6 times 49 plus 2 times 7 plus 4 times 1. Altogether, that gives us 12,005 plus 1,029 plus 294 plus 14 plus 4. And that gives us 13346 base 10. So we have 53624 base 7 as 13346 base 10. Which of our options is correct? Is it A, B, C, or D? Option D is correct. 13346 base 10. Next, we'll try the second question. Convert 1011000101 base 2 to the corresponding base 10 number. To do that, we'll also follow the first example or the first question that we just answered to rewrite our number in its expanded positional form. Okay, that would give us 1 times 2 raised to the power 8 plus 0 times 2 raised to the power 7 plus 1 times 2 raised to the power 6 plus 1 times 2 raised to the power 5 plus 0 times 2 raised to the power 4 plus 0 times 2 raised to the power 3 plus 1 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. Okay, that gives us 1 times 2, 5, 6 plus 0 plus 1 times 64 plus 1 times 32 plus 0 plus 0 plus 1 times 4 plus 0 plus 1 times 1. And that gives us 256. That is 1 times 256 is 256. Plus 1 times 64 is 64. Plus 1 times 32 is 32. 1 times 4 is 4. Plus 1 times 1 is 1. Altogether gives us 357 base 10. So we have our answer as 357 base 10. Which of these options is correct? Is it A, B, C, or D? Option B is correct. 357 base 10. And with that, guys, we've come to the end of our class for today. I'm sure you've learned quite a lot. Till I see you in the next exciting class. Take care and be the best that you can be. Bye for now.
If you enjoyed this video, hit the like button, drop a comment, and subscribe to our channel. You can also turn on notifications to stay updated on new videos on this channel. This Brain Friend video was brought to you by Synforest. For more of these amazing e-learning videos, get your copy of Brain Friend. With more than 1,000 e-learning videos, over 74,000 test items in more than 40 subjects, a career counseling guide, and many other amazing features, BrainFriend remains your foremost e-learning and exam preparatory software. BrainFriend. Learn better, make excellent grades.